Hello dear students, my name is Adil Yusuf from Computer Science Engineering Department, and today we will discuss divide and conquer strategy in design and analysis of algorithm. As we know, it is an important design strategy. By design strategy we mean it's an approach to solve a particular problem. In divide and conquer, basically we divide, it's composed of three steps. First step is divide, right? In this we divide the original problem in a stance into several sub problems, P1, P2, P3 and so on up to Pk. Let us suppose we have a problem P and we solve this sub problem P into several sub problems P1, P2, P3 and so on up to Pk. One more thing I would like to clear over here, these sub problems should be of the same type as that of the original sub problem. For example, if the original sub problem is searching, when we divide this original sub problem into smaller instances, the smaller instances like P1, P2, P3 and so on, these should be of the same type as that of the original problem, right? This is the point which is to be noted over here. And after that divide we conquer, or we can say solve these sub problems. These sub problems are solved recursively. Means we find the solution of each of these sub problems recursively, right? Then after that we combine the solutions. Like if we have a problem P, we divide the sub problem into P1, P2, P3 and so on up to Pk. Then we solve each of these sub problems recursively and then we combine the solution of these sub problems. It is not mandatory always to combine. For example, if we take the case of searching technique, when we divide in searching technique, we are given a list of items like an array. Let's suppose we have, if we take the example of binary search, when we divide this at some position, I will talk in the next lecture, we divide it into two arrays, and after that the element which is to be found, we divide this array on that element basis. So after that when we divide it, we conquer only one array based on that element. Similarly until we reach the base case and find the element. But in case of sorting technique, if we take this sorting, for example merge sort, when we are given the list of items, when we divide the list into sub problems and then further sub problems, then we combine. Means here we combine the base cases. When we reach the base case, we combine them and find the solution of the original sub problem. Now we will take an example. Before going to an example, let us discuss about the running time of an algorithm. T of n is equivalent to AT n by b plus f of n. Now as we know, we have a bigger problem in instance P and we divide this problem in instance into a number of sub problems, right? Or we can say k number of sub problems. So this A is the number of sub problems, right? And this n by b, it is the size of each sub problem. This b should be greater or equal to 1. Do you know why? Because the size of each sub problem should be greater or equal to 1. If we take b is equal to 1, so what does that mean? It means the size of sub problem is also equal to 1. So it should be n by b and b should be greater or equal to 1. Means we can divide the sub problems into smaller sub problems, more than one sub problem, right? So it is also called as the recurrence relation. As we know, recurrence relation, it is a relation which is represented in terms, in which next term is represented in terms of its previous term. As we know, these recurrences can be solved using master method. We have substitution method and etc. etc. Iterative method, recursive tree method, and so on. Now we will discuss an example of this divide and conquer. That is, how do we detect a counterfeit coin? Suppose we are given a bag of items, bag of coins, and in that bag there is a counterfeit coin. That is counterfeit coin. Let us put it in a simpler words. We are given a bag, and in that bag we have 16 coins, right? And among these 16 coins, one coin is counterfeit. By counterfeit we mean the counterfeit coin has a weight less as compared to the genuine coins, right? Means if we take a bag of 16 coins, one coin is counterfeit. So how do we find it? If we find it by simply comparison, we will compare first coin and second coin, and we check if, and we weigh them. There is a machine which is used to weigh these two coins. If we weigh them, if they are equal in weight, means no counterfeit coin, right? And if weight of the first coin is greater than second, we say second coin is counterfeit. So if there is no counterfeit coin, we will compare 3 and 4. Similarly, we compare them. If weight is equal, no counterfeit coin. If there is mismatch in the weights, so the lighter one is the counterfeit coin. Similarly, we can weigh 5 and 6, right? So means then we compare 5 and 6. Same procedure, then 7 and so on up to 15 and 16. Means in worst case we have to compare all the coins. So what are the how many comparisons we have done? We have done 8 comparisons. And at the end, if there is no counterfeit coin, so what we have done? We have done 8 comparisons, and at the end we didn't find any counterfeit coin. So this approach is not good. Here we can use divide and conquer strategy to detect a counterfeit coin in a bag of coins. Let us suppose we are given same question, 16 coins, and we use design strategy divide and conquer. When we use divide and conquer, what we will do? We will divide this bag into, means the 16 coins can be divided. These are bigger sub problems, P. We can divide this problem into smaller instances, means 8 coins and 8 coins. So we can take 2 sets of 8 coins each. Then we compare them. Then we weigh them. The set which is lighter one will contain the counterfeit coin. Means when we compare, let us suppose it is set A and it is set B. When we compare them, if they are equal, what did we find? We found that no counterfeit coin. Are you getting? Means here in the first comparison we have decided whether a bag contains a counterfeit coin or not. In the first approach which we have followed, here we have to compare 8 times. Means we have done 8 comparisons over here, and at the end we didn't find any counterfeit coin. But here in the first comparison we have decided whether the bag contains a counterfeit coin or not. Using what approach? Divide and conquer approach. So when we compare them, let us suppose A is greater than B. Means the weight of A is greater than the weight of B. What does that mean? It means the bag B is lighter, or we can say the set B is lighter. Means the set B contains the counterfeit coin. What will we do again? We again divide this problem into smaller instances. I will say B1 and B2. Then again I will compare. Now it has 8 coins because A8, B8. Now when we divide it, it contains 4 coins, right? Similarly, it contains 4 coins. Again I weigh them. The set which is lighter will contain the counterfeit coin. Let us suppose B1 and B2. B2 is lighter, so B2 contains the counterfeit. Again I will divide it. The divide and conquer strategy. So it would be, let us suppose B21 B2 2. So B2 1 will contain 2 coins, it also will contain 2. Then again I will weigh them. The lighter one will contain the counterfeit coin. Let us suppose this contains the counterfeit coin. So again when I will further divide it, it will contain 1 coin, it will contain 1. Again I will weigh them. When I weigh them, सीधी सी बात है, it is obvious that the one which is lighter is the counterfeit coin. This is by using divide and conquer strategy. Means only few comparisons as compared to the previous one which you have followed. So this is an example how to detect a counterfeit coin using divide and conquer strategy. Okay, now we will discuss the algorithm for this divide and conquer strategy. See here, control of abstraction, right? We have algorithm divide and conquer, and P is the original subproblem. Means P can be bigger or it can be smaller. Now we will check the base case. If small p means the smaller instance of the problem. For example, if we take the searching technique. In searching, if we are given only one element, an array of only one element, let us suppose 5, and we have to check whether an element is present in this or not. So it is itself a base case. It is small p. When it is small p, then it will return directly the solution of p. It can be either true or false. Means if we are searching for 5, so it will directly return 5. Or if we are searching for, let us suppose 7, so it will return false, means 7 is not present. So it is the base case. Means small p means when we are given the base case, smaller instance of the problem. Else what we will do? We will divide this p into smaller instances, sub problems of same type. Again I am repeating, when we are dividing this problem into smaller instances, let us suppose p1, p2, so on up to pk. These sub problems should be of same type. It is not like I am giving you an example of this searching, then the sub problems might not be searching. So it should be, the sub problems should be of same type. Means I am dividing p into smaller instances, p1, p2, so on up to pk, right? And after that, what I will do? I will apply divide and conquer to each of these sub problems. Means like we have decided, we have seen in counterfeit coin. We have divided a bag of 16 coins into 8 and 8. This is also a set of coins, means same type. Then again I am dividing it into, means we are dividing each problem into smaller instances until we reach the base case. Means 1 1 tak hum when we reach up to the base case. So we apply divide and conquer to each of these sub problems. Then we return the combine. After that we combine these and find the solution to the sub problem. This is the algorithm for divide and conquer. See, in divide and conquer there are some pros and cons to it. First, what is the pro? Divide and conquer supports parallelism. As we know, the original problem P is divided into sub problems. So these sub problems are independent, P1, P2, so on up to Pk. When these are independent, it means these can be run on a multiprocessor system. So as it supports parallelism, so these can be run on multiprocessor system because the sub problems are independent of each other. Now what is its disadvantage? As we know, this most of these algorithms are designed using recursion. As we know, in recursion the memory management is high, right? As stacks are used for the recursive function. So this was something about divide and conquer. Thank you.